Hi, my name is Brittany, and today we'll be talking about the number e. The following is one of the most important exponential functions and its graph. Number e can be applied to concepts such as Newton's law of cooling and compounded interests. To find the value of e to the power of 4.243, you'll need a scientific calculator. Find your e button and type in the number as shown. We'll start with compounded interest. In the formula for compounded interest, A is the account balance, P is the beginning amount, R is the annual interest rate, N is the number of times the interest is compounded in 1 year, and T is time, respectively, in years. First, you're going to want to plug everything into the compounded interest formula. First, Brent invested his $700, so that will be our principal amount. He was offered 4.5% APR, so after we change that number into a decimal, this will be our annual interest rate. The interest was compounded quarterly, so 4 will be the number of times per year the interest is compounded. We want to know how much his account will hold after 4 years, so 4 will be time. First, we divide what's inside the parentheses and multiply to find our exponent. Use a calculator for this part. We take what is inside our parentheses and raise it to the power of 16. That's roughly what our equation looks like now. So now we need to multiply by 700. Now I'm going to take our answer and multiply it by 700. After 4 years, this is how much money will be in the account. Another way interest can be compounded is continuously, and this is the formula. This will be another bank option for Brent, so we will write our equation just as before, with 700 as our principal amount. Our interest rate was 4.4%, so we change that to a decimal and plug it in for R. Our time will be again 4 years, and from here we can start solving. So we can use our calculator to solve it. We're just going to do 700 multiply it by E, and then type in our exponent, which is 0.176. Close our parenthesis and solve. This is the account balance after 4 years in an account that offers 4.4% compounded continuously. Now you can use the knowledge you've learned to find the balance of the account under the following conditions. Now we'll look at Newton's law of cooling. In this equation, Y is the temperature of the cooling object. A and K are constants related to the object. T is the time elapsed since the object began cooling, and C is the temperature surrounding the object. So we're going to use the equation for Newton's law of cooling to find the temperature of Janet's soup. Constant, so I just went ahead and plugged those in, 140, and remember it's negative K, so negative 0.01. We want to know how hot our soup will be after 10 minutes, so T equals 10. Finally, for our equation, the temperature of the medium surrounding the object was 70 degrees. So this is our equation so far. Remember, you always want to multiply before you add. So I'm going to go ahead and multiply using my calculator. And also using my calculator, I'm going to add. So I'm going to add 70 degrees. So after 10 minutes, the soup will be approximately 197 degrees Fahrenheit.